So my name is Rob Harwood. I'm going to talk a little bit about some of the work that we're doing in place-based digital twins, with specific focus on net zero and climate resilience. But I also want to compare and contrast with where the bulk of my background has been in, which has been in advanced product design and development, where digital twins, or whatever you want to call them, that connected cyber-physical system in one way, shape or form has been used for decades, and just talk about some of the lessons or some of the things and differences that we might see. But I thought I'd start with a little bit of interactivity. I don't know if any of you follow the Gartner hype cycle. Does that mean anything to you? Well, the last one I could find, that's free anyway, and the last one I could find was the 2018 version. And digital twins were right at the top of the hype cycle, which means we're just on the precipice of cascading over to everybody going, Christ, not another digital twin, right? So I just thought I'd just have a little show of hands, and this may work or it may not. So my organization or yourself, depending if you're just representing yourself, do you know what a digital twin is? Yes, show of hands. Most people. It might be a self-selecting audience given the topic is digital twins, but you know. We know what one is, but we're not investing in it. And quite a few nodding heads. We're trying to figure out how to invest in it. We know we need one, but we've no idea what to do. Some nodding heads. We're running a pilot. Yeah, some nodding heads. We've got operational digital twins. Who's actually got them operationalized in their business? I'm not seeing any nodding heads. We've tried and we've said no way. Nope. Okay, so we're still early. We're still early in that adoption. We're still in that learning phase. That's interesting. All right, so apologies for the eye chart, and you don't have to read all the words. I'll try my best to translate. So I would argue that advanced product design and development leads the way in the use of digital twins. And I thought I'd try and pick a classic British institution that's not too far from Sheffield. I know Derby's the wrong side of the county, but it's close enough. So Rolls-Royce, right? And I don't know if anybody's seen or familiar with the A maturity model. I'm sure there are several out there, but starting with, data, have we got our stuff together? All the way through descriptive, diagnostic, predictive, prescriptive, and now with the advent of AI and ML, we're getting into this whole cognitive way of dealing with analytics, right? And if you just break down what Rolls-Royce are doing with their engines, and people say, oh, well, my system's way more complex than an aircraft engine. I'd challenge that, right? An aircraft engine has 18,000 individual components that all have to work without fail, ever. It delivers the power, so you often just see that when you sat on the aeroplane. That's what happens when you take the skin away. It delivers the power of 68 Formula One cars, right? It's an incredible amount of power. The load on one fan blade alone is the weight of 9 London buses, 90 tons on the end of one of those fan blades when it's spinning. And it's sucking in 1.3 tons of air every second when it's taking off. So that's a complex system to try and make work. So Rolls-Royce and others like them have been, and I think you used the word, John, digital twin, been around for a long time. May have been called a digital twin, but that closed loop between physical and cyber has been around for a while. So they've got the program, the intelligent engine. They're creating billions of data points on every flight about their engines. They have an engine health monitoring system, so it sends alerts. Bang, there's something going wrong here. But they also have smart analytics and their smart discovery platform, which starts to get into the, hey, what is actually going on? Why is this happening? And they do fully integrated systems level simulation, not just point solution, just look at the structure, just look at the fluid. They're looking at everything in a highly integrated sense. They've got a digital twin program. They're starting to connect it all together. And they've already, that was a 2018 quote. So they're 5 years into investing in artificial intelligence to help them improve their operational availability. So I would argue that physics-based simulation has got a lot to teach. Advanced product design and development's got a lot to teach what we're trying to do in place-based and analytics, and I'll get to that in a minute. But here's a quiz question for you. Everybody likes a drink and a quiz on a Monday night, right? So just pretend you're in the pub. So between X% and Y% of digital transformation projects fail. And it depends whether you listen to McKinsey, Forbes, or Bain, right? Who thinks it's between 30 and 50? One, the lone wolf. Who thinks it's between 45 and 75? Maybe half. Who thinks it's between 70 and 95? Yeah, maybe the other half, maybe just shading it. Well, you're right. Between 70 and 95% of digital transformation, including digital twin initiatives in these big companies and other companies, fail. Forbes puts it somewhere in the middle at about 84%. So the odds are stacked against us. You can start to read, why do these things, why do they not work, right? There are a lot of reasons. 3 that stand out. Lack of alignment to business outcomes. There's a focus on the technology and not the outcome. And we're here talking about digital twins today. Who wants a digital twin? Nobody. Think of the analogy between a drill and the hole. If you're talking to the customer, you're talking to the business, they don't want a drill, they don't want a digital twin, they want what a digital twin delivers. But we all fall in love with the drill, and we need to fall in love with the hole in the wall because that's what's going to hang the pitch, that's where the picture's going, and that's what's going to hang up. So we need to focus on that. Lose the shiny toy syndrome. And the other focus is on training and skills. We have a massive digital shortage in the UK, and it's a global phenomenon. There are something like 250,000 open data science positions in the UK right now. So we've got a huge shortage of skills. So we need to make these technologies highly accessible as well. So if I flip now, and I said I was going to talk about place-based digital twins, so things that happen in regions, in locales, and so forth. I don't know if anybody is in that kind of place-based digital twin space, but this is where we focus as a company and the applications that we're doing with specific focus on net zero and climate resilience applications. So trying to apply this technology to either accelerate our journey to net zero or help us deal with the here and now in terms of climate resilience. And I would argue that at best, we're here on this journey. Data's highly fragmented. Lots of it's just still stuck in spreadsheets on Joe's laptop down the corridor in the local authority. There's moves to make open data. Modeling and simulation is unidimensional and very siloed, so you might do a traffic simulation, you might do a flood simulation, but you don't do the two together. When in reality, when you have a flood, you need to understand where the vulnerable people are, where the vulnerable assets are, and so forth. You only get that when you do both, right? There's a heavy reliance on third-party, expensive consultants. Apologies to any sponsors who may be here who are third-party, expensive consultants. But there's a heavy reliance on them. Strategy's fragmented. Rolls-Royce are designing the best jet engine. Nobody's out here designing the best climate-resilient city or the best net-zero city. They're building a climate plan, a traffic plan, and an energy plan, and they're not talking to each other about the 3. So we've got a long way to go to build that systems view. And there's really a lack of clarity on value creation and use cases. So I would say at best we're there. Some towns and regions that we talk to are certainly here. There are a lot down here. So we've got a lot to do. So what are we doing? What we're trying to do is tackle some of the biggest challenges that we see in that adoption. So we position ourselves as a decision intelligence provider, which means we're using data, advanced data science, to try and solve that problem and tackle climate resilience and net zero applications. We were founded in 2019. We're a spin out of the University of Leeds. We've had over £5 million of venture capital funding since founding. We got 3 million just last year. So we've got some really good core tech. We've got a product out called Compass Engine, and we're a founding member of the Digital Twin Consortium, which is an object management group-led industry body out of the US. And we use some core technology called graph technology under the hood. And again, I'm going to show some Gartner stuff here to try and give it some independent credibility. Again, it's a bit of an eye chart, but this is their emerging technologies and trends impact radar. It's worth taking a look at that every year when they publish it. And they talk about some of the key things that are driving either the productivity revolution or the smart world, the areas that we live in. There's things on cybersecurity and privacy as well. They talk about some of the key technologies. You can see digital twins is right in there as getting close to maturity. But one of the critical enabling technologies is something called knowledge graphs and graph technology. And that's the foundation of what we do with both data and with models and simulations. That's what enables us to hook everything together and connect it together. If you're not familiar with knowledge graphs, and please don't test me, I'm not on the technical side of the organization, the analogy is like going from an encyclopedia to Wikipedia. So if you think about the way we organize and manage data and models and simulations today, they're like pages in an encyclopedia. They're quite unidimensional. Each page has a lot of information, but page 5 and page 125 don't know anything about each other, even though they may have context and they may be talking about something similar. So you as an individual have to wind through the contents page and try and make sense of everything that's going on. Compare that to Wikipedia. You ask a question, and it tells you the answer to that question, and everything that's related to it gets connected and surfaced for you, and it's just hyperlinks. We're doing the same for scientific, technical, and engineering data sets. And that means you can get to decision-making way faster than you can with traditional models. Digital twins, this is a government publication, Improving Infrastructure Performance 2050, puts data and digital twins right at the middle of connecting SDGs with the stuff that we need to do on the ground. So this is the area, this is the critical piece of technology we need to develop. And we're starting to do that. And we've got a whole bunch of use cases. I'm not going to bore you with all these videos. I'll just give you a few examples of the work that we're doing with national government, Department of Transport, local authorities. This example here is looking at where to place low emission zones most effectively and just rapidly optioneering through that. This is a project around housing regeneration where you're not just looking at it from a carbon perspective of, say, hey, insulating these housing better, but how do you do that and get people out of fuel poverty at the same time? So it's a socioeconomic and carbon calculation that's coupled together. It's not unidimensional. And you get a different answer when you merge things together. And this is a project we've got going on with Westminster right now, Westminster Council, which is looking at school streets, so they close the roads between 7:30 and 9:30 and between 2 and 4. Where do you put those displaced traffic? If that traffic starts going down streets where you've got houses with low EPC rating, well, those buildings, those people who live there are going to be adversely affected by noise and the emissions that you're diverting. So is it a just transition, or is it just moving a problem from one place to another? And then most pertinently is something like this, which is where we get the coupling of different simulations where if we have a flood, and it's very relevant right now with the horrendous things that happen in Chesterfield and around, where we actually started to look at if you do connect a flood simulation and flood data with traffic simulation, how can you very quickly optioneer and analyze how you should respond to that? And this is just how we're trying to deliver that capability. You'll see there's no coding here. You don't really know you're using modeling and simulation. You're using tools in the background that will give you quick directional insight into the types of responses that you can develop over time. And we've done that by pre-packaging data, pre-packaging analytics and simulation, and giving you the ability to rapidly analyze. And here you start to see RAG networks of the worst impacted properties, the worst impacted people, and the worst impacted roads. And that's coupling traffic and flood simulation. So that's it. Probably more than 10 minutes, Chris. I apologize. But follow us on LinkedIn, follow us on the website, and if you've got any questions, you can happily contact me. So thank you.